That's scary. Don't be scared. Thanks for drawing my little graph. Oh, you're welcome. I did this for everybody. Oh, wow. I was feeling really nice last night. Okay. So, we're starting a new unit today, and this unit is called Systems of Equations and Inequalities. Let's start by writing our objective for today's lesson on the board, or on your paper. It's written over there on the sideboard. So what we want to be able to do today is to solve a system of equations using, so a system could have infinitely many equations in it, but we're just going to look at 2 equations. And what we're going to do, what we're going to use to solve our system of equations is a graph, and we're also going to use a table. Okay? So, yeah, so a system, just in general, right? I'm sure you've heard the word system before. It's just something that is that has a whole bunch of different parts that all work together for one goal, right? Exactly. Yeah, exactly. Yeah, like, you know, you think of a computer, you just think of one thing, but in reality, right? Like I have a monitor and a desk, like I have the monitor and the computer and a keyboard and a mouse. They're all those different parts working together, and then everything inside the computer. Exactly. Or I gave you the example of a water cycle. You can label it or not if you want. But right, we've got clouds, sun, we have groundwater, right? We have rain and snow. And all those different parts work together to, you know, contribute to this flow of water within nature, right? And do we remember the different parts of the water cycle? What happens when groundwater goes up into the clouds? No, not condensation. Evaporation. Evaporation. You guys are right, though. Right on. Got evaporation. Yeah, how does it change from like clouds into rain? What is that? Condensation. You're not going to be tested on this, don't worry. I'm just making an analogy. Yeah. And then what about rain and snow turning into groundwater? What's that? Or the rain and snow falling. No, what's the other one? Precipitation, right? Good. Yeah, so we know that our equations are not just lines on a graph, right? They represent something. So a system of equations is just representing multiple things, but using the same variables, okay? So let's just get another visual here. So you can draw in this first coordinate plane, I want you to just draw a line, any line, something maybe like that. Does that have a positive or a negative slope?
That's positive.
That's a positive slope, right? So this plus, then draw a second line on the second box.
Do they have to be like those, or can they just be red?
They can be anything you want. But then on the third coordinate plane, I want you to draw them both together. Right? So something like that. Yeah? So we're taking what we've been doing, where we're just graphing one equation at a time, and now we're just putting them together on the same coordinate plane.
We just wrote 2 slopes in one graph.
Huh?
We just wrote 2 slopes in one graph.
Mm-hmm. Yeah, 2 lines on one graph, right? And I'm going to give you a little sneak peek. This point right here, where the 2 lines intersect, that is going to be really important. That is our solution. So the intersection is the solution. And if I wanted to like tell you where this point was, how would I explain this point to you? What would I have to use to explain? The coordinates, exactly, that's what I'm looking for. So the solution of a system of equations is always an ordered pair. Always an ordered pair. Okay?
What about that one bridge thing?
What one bridge thing?
That one paper that we did with the car stuff.
Yes, exactly. Yeah, exactly. That's exactly it. So we looked at 3 different cars that day, and we looked at them driving different directions and different speeds. And remember, it was the intersection was where those cars all met. But we're going to go to the next page. I need to open it up. Huh? Yeah, they were driving from the Mackinac Bridge and from Flint. And they met somewhere in the middle. So let's go to this page, please. And we're going to look at an example. So what Lucas is talking about is a problem we did last semester, and we looked at cars driving on the freeway. Now we're going to look at an example that looks at trees, that looks at 2 different types of trees that were planted at different times and that grow at different rates, right? So then we're going to we're just going to model that situation, okay? So first step, let me just get this situated. It's a tree. It's actually 2 trees is what we're looking at. Looking at a magnolia tree and then a pear tree. Okay, so this magnolia tree was planted by someone named Polly. And when she planted the tree, it was 4 feet tall. So when she put it in the ground, it was already 4 feet tall. And then at the end of each year, she measured the height of the tree. And she collected that data in a table, right? So we're going to use this table to create a linear graph. So we're going to go from table to graph, right? So just to be clear, right? When she planted the tree, it was 4 feet tall. After the first year, how tall was the tree? 6 feet. How tall was it after the second year? 8 feet, and then 10, and then 12, right? So let's go ahead and graph that. So at 0 year is on the horizontal axis, height is on the vertical axis, right? So at year 0, the tree was 4 feet tall, so that can be our first point. I'm going to do 2 different colors, right? After the first year, the tree was at 6 feet. After the second year, it was at 8 feet. And the third year is at 10 feet. And the fourth year is at 12 feet. Where do you think it'd be at the 5th year? 14. Yeah, exactly. So let's connect those points together. And we've got our linear graph that models the growth of this magnolia tree. Right? Can we do the same thing for the pear tree? Do the same thing for the pear tree? Why not? Why not?
Because they don't have the year and height.
Oh, they don't have the table, right? They give us an equation instead. Right? So we've got our equation. What form is this in?
Intercept form?
Yeah, slope intercept form. And what's my slope? What's my intercept?
This one. But there's no intercept on it.
Yeah, right. Slope intercept form, right, is y equals mx plus b.
What's
b?
Your slope. Intercept.
What? What's b?
Your slope. Or not your slope, your intercept.
Your y-intercept, right? And what's the number right before x? What's the coefficient of x? That's the slope.
But can't we still graph it without the intercept?
Yeah. So there's no intercept that shows up right here, right? You can't see it. But if I were to put plus 0,
then you just start at 0.
That's exactly what it is, right? So when you don't see the y-intercept there, the y-intercept is at 0. So can you find 0 on the y-axis and plot a point there?
Mm-hmm.
Find 0 on the y-axis and plot a point there.
This one moves pretty fast.
And then what's the slope in this equation?
It's 4.
Right?
4, 1.
It's the number right before x. It's at 4. And yeah, how do you write 4 as a fraction?
4 over 1.
4 is 4 over 1, right? So what's my rise from this slope? 4. And what's my run? 1. So from my y-intercept, I need to count up 4 over 1. And notice that they're counting by 2's on the y-axis, right? And they're counting by 1 on the x-axis. So don't count up 4 lines. Count only up to 4 and over 1, right? Up 4 over 1. Up 4 over 1. 4 over 1. And connect your points together. Now, I'm going to have you do this part C on your own. I want to see what you can gather from this. So, first part asks about the unit rate for the Magnolia tree and for the Pear tree. How fast, how many feet does each tree grow per year? Look at your graphs. And that rate, that is related to your slope, right? So look to see how many feet does each tree grow per year, and then answer the question, which one grows faster? And then the next step, I want you to draw both graphs. So just copy both. Yep, how many feet per year? And then in this third graph down here, I want you to draw both graphs, both of those lines here. Both of the lines there. So copy both graphs. Oh, yeah, it's been. Hey, Corbin, how is your Chromebook? Is it still working there? No. It's fixed? Yeah. It's not? Okay.
It's sitting down.
Okay. Yep. And make sure. Your slope is 4, right? So you can go up 4 over 1. Yeah? You went up 8 over 1. You just counted 1, 2, 3, 4. 4. Okay. So, how many feet Magnolia tree grow? 4 to 6. So once you draw both graphs down there at the bottom of the page, it asks to circle that point of intersection. And then I want you to tell me, what do you think that point represents? What does that tell us in terms of the trees?
Wait, how far did it go?
What do you mean? So draw the whole, yeah, cover the whole, yeah, through 4 years.
6. For 6 feet.
Started at the 0 year, it was 4 feet tall, right? And then at the first year, it was 6 feet tall. So how many feet did it grow in 1 year? I told you to. So look here. So it started at 4 feet tall, right? And then after 1 year, it was 6 feet tall. So how many feet did it grow in that 1 year? It went from 4 to 6. How many feet was that? From 4 to 6. That's 1 year, yeah. But how many feet? You started at 4 feet and you went up to 6 feet. How many feet is that? 2, right? 6 minus 4. You see that? Yes. So that's what you're putting there. And then what about the pear tree? How many feet did it grow in 1 year? Not 2. Where does it start out at? And where does it end at after the first year? So how many feet does it grow in a year? Yeah. Which one grows faster? Yeah. Yeah. And so now, make sure you connect these dots. And then copy both graphs on here. Okay? And circle where they intersect. What does that point represent? Okay. So once you're done with that, I'd like you to take out your Chromebooks. And I'm going to get you set up on a Khan Academy assignment.
Are we gonna turn these in today?
Yep, that's perfect. In the what year are they? Yes, I am going to have you turn that in at the end of class. But take out your Chromebooks, please. Go to our Google Classroom. Classroom. And I posted a Khan Academy assignment there. So this is the Google Classroom.